Alright, in this video here I'm going to be talking about the inverse cosine function and just evaluating the inverse cosine function. So if you didn't see the other video that I did on the explanation of the definition of the inverse cosine function and where it comes from and how we have to limit the domain and all that stuff, I would definitely advise you to check that one out before you watch this one, because then you'll have a better understanding of why we're doing the things that we do here. Right? But just a couple of quick reminders from things we talked about on that video. Remember, the cosine inverse function, I had to take the cosine function, the graph of the cosine function, and limit the domain. Right? I had to limit it between 0 and pi in order to make the function 1-to-1, in order for it to have an inverse. And in the video I did, I explained that in a lot more detail. But remember, I do limit the domain of my cosine function between 0 and pi, which means when I'm evaluating the inverse cosine function, I can only use values of the unit circle between 0 and pi, which means I'm only looking at the top half of the unit circle, which is why up here when I drew the unit circle, I only drew the top half of the circle, because for inverse cosine, anything on the bottom of the unit circle is completely irrelevant to what we're doing, right? For the cosine function, it was between 0 and pi. That's how I broke apart my function to make it 1-to-1, and so that's what I use when I go to the unit circle, right? And like I said, that other video I did, I explained that in a little bit more detail, so you can watch that if what I just said didn't quite make sense to you. All right, so what I want to do now is evaluate these inverse cosine functions. All right, so a couple things when you're evaluating inverse cosine. First off, when you see cosine inverse, that should tell you right away, all right, cosine inverse, I'm looking at just the top half of the unit circle. That's all I need to look at from the unit circle. And then cosine tells me I'm looking for the x-coordinate of my terminal point. All right, so cosine inverse is the x-coordinate from the top half. Right, and if you watch the videos that I did on sine inverse, I did a couple on those. Sine inverse was a different part of the unit circle, and it was looking at the y-coordinate instead of the x. Right, and which one you're looking for, the x or the y, goes back to the definitions of the trigonometric functions. Right, the cosine function gives you the x-coordinate of your terminal point on the unit circle. So when I do cosine inverse, I'm looking for that x-coordinate. All right, so what I'm doing now, cosine inverse of root 3 over 2, I'm looking for the point on the top half of the unit circle that has an x-coordinate of root 3 over 2. All right, so I did not put the points up here on the unit circle. We'll figure those out as we go. I did put the pi numbers up for the first and second quadrant. And if you didn't watch the video that I did on like how to label the unit circle and how to figure out what all the numbers are and everything, and that this is 5 pi over 6 and 3 pi over 4 and so on, watch that video where I go through like the complete unit circle and how to figure it out. At this point, I'm assuming that you know how to do that, so I'm not going to really explain why these numbers are what they are. All right, so I'm looking for cosine inverse of root 3 over 2, so I'm going to go to my trig hand, right? Cosine inverse, I'm looking for an x of root 3 over 2. Remember, when you use the trig hand, the x coordinate comes from the number of fingers above the one that you put down. So if I put down my ring finger, I have 3 above and 1 below. All right, so for the ring finger, which corresponds to the first one up here, pi over 6, my x-coordinate is root 3 over 2, and my y-coordinate is 1/2. All right, and again, that comes from trig hand. If you didn't see the video I did on trig hand, watch that one because it kind of explains how to do all that. All right, so for pi over 6, I have root 3 over 2, 1/2, and my x-coordinate is root 3 over 2. That's what I'm looking for here. So cosine inverse of root 3 over 2 is pi over 6. Right, because if I do cosine of pi over 6, that equals the square root of 3 over 2. Right, remember, inverse functions switch the inputs and the outputs. So when I'm doing the cosine function, it gives me one of the pi numbers, and I have to give the x-coordinate of that terminal point. For the cosine inverse, they're giving me the x-coordinate of the terminal point, and I have to find which pi number has that x-coordinate. Right, so it's like the problems that you've done probably already with the cosine function. It's just doing them backwards. Right, I'm looking for the output value. I'm looking for the x-coordinate, and I have to give that pi number as my answer. Right? It's just, you're still using the unit circle, you're just looking at different numbers on the unit circle and kind of putting them together backwards of what you probably did before. All right, so cosine inverse of root 3 over 2 is pi over 6. All right, cosine inverse of 0. All right, so once again, cosine inverse, I'm looking at the top half of the unit circle. Cosine tells me I'm looking for the x-coordinate, and I want an x-coordinate of 0. All right, so where on the top half of the unit circle is the x-coordinate going to be 0? Well, it's going to be up here on the y-axis at pi over 2. Right, pi over 2 has the coordinates of 0, 1, and that's where my x is equal to 0. That's what I'm looking for here. So cosine inverse of 0 is pi over 2, because cosine of pi over 2 equals 0. Right? Again, inverse functions switch your inputs and outputs. Right, so for cosine inverse, that's all we're doing. Top half of the unit circle, cosine is the x. I'm looking for whatever number they give me, I'm looking for that as the x-coordinate of my point, and I have to give the pi number as my answer. All right, cosine inverse of negative 1/2. All right, so I'm looking for an x-coordinate of negative 1/2 from the top half of the unit circle. Well, I already know which quadrant it's going to be in. If my x-coordinate is negative, it's not going to be from quadrant 1, right? Quadrant 1 has all positive x-coordinates. Quadrant 2 is where I have negative x-coordinates. Right, so I know if I'm looking for cosine inverse of negative 1/2, it's going to be one of these numbers from the second quadrant. It's got to be, because it has a negative x-coordinate. All right, so the question then is, well, which one has negative 1/2? Well, once again, I'm going to use my trig hand and then just reflect the point over to the other side. So if I want x equal to 1/2, I put down my index finger. I have 1 up above, so that's 1/2 for the x, and then root 3 over 2 for the y, and the index finger corresponds to the pi over 3. All right, so the coordinates for pi over 3 are going to be 1/2, comma, root 3 over 2. All right, now that's not what I'm looking for, though, because I want my x to be negative 1/2. So what I do then is I reflect this over to the other side. Right, 2 pi over 3 in the second quadrant is going to have the coordinates negative 1/2, root 3 over 2. All right, remember, if you can use your trig hand to get the terminal points for everything in the first quadrant, and then for any other quadrant, you just reflect. You use the symmetries of the unit circle. Right, the pi over 3 numbers have the same coordinates, except in this quadrant number 2, x is negative and y is positive. Right, so here I have x equal to negative 1/2, which is what I'm looking for. So cosine inverse of negative 1/2 is going to be 2 pi over 3. Right, so being able to do this and evaluate these inverse trig functions, you have to understand the unit circle. You have to be able to get your terminal points. You have to know where those pi numbers are. And if you're not comfortable with that, go back and watch some of the videos I did. I did a whole bunch on the unit circle itself, on the terminal points, on how to find the terminal points, how to evaluate the different trig functions. In order to do the inverse trig functions, you have to be comfortable with all that other stuff that comes before it. Right, so cosine inverse of negative 1/2 equals 2 pi over 3, because if I do cosine of 2 pi over 3, I get negative 1/2. All right, now for any one of these, you might say, well, sure, cosine of pi over 6 equals root 3 over 2, but there's another point down here in the fourth quadrant that also has an x-coordinate of root 3 over 2, so why don't I give that as the answer? Well, remember, if the inverse function is going to be a function, that means for each input value, you can only have one output. Right, so even though there are 2 points on the unit circle that have an x of root 3 over 2, it will be pi over 6, and it will be down here at 11 pi over 6. I can only give one of those as my answer because the inverse cosine function can only have one output for each input, and that's why we limit the domain and just talk about that top half of the unit circle. That allows us to just give one single output for no matter what number is in here. All right, so just another reason why we have to limit our unit circle to just the top half. All right. The next one down here, cosine inverse of negative 0.37. Well, if I look around the unit circle, and you don't have to write all the numbers on there to figure this out, but of all the numbers I know, they're all either 1 or 0 or root 3 over 2, root 2 over 2, or 1/2, or the negatives of those. Right? Negative 0.37 is not any of those numbers I just mentioned. Right? Negative 0.37 is not one of the numbers I know from the unit circle. And so if I have to do the cosine inverse of a number that's not on the unit circle, I have to use a calculator to do that. Right? Any scientific or graphing calculator should have a cosine inverse button. All those calculators should have sine, cosine, tangent, and also the inverses of all those three. And usually they share the same button. If the people who design the calculator are in any way competent, they're going to have them share the same button, so it's easy to find. Right? So the people that do the TI-84 over there at Texas Instruments, they're competent. So right, the cosine button is there. If you look above the cosine button, I don't know if you can see it. But in blue it says cosine inverse, right? The cosine with a -1. So if I want to do an inverse cosine, I do the second button and then the cosine button, right? That gives me the cosine inverse. And then I type in my number, negative 0.37, and then I hit enter. And cosine inverse of negative 0.37 is 1.949, whatever it is, 1.9498, approximately. Right? Most of the numbers you get from the the inverse trig functions, most of them are going to be irrational numbers, so you have to round them off at some point, right? So that is our cosine inverse of negative 0.37, right? So if you have these numbers that you should know from the unit circle, the 1/2, the root 3's over 2, root 2's over 2, 0 or 1, or the negatives of those, you use the unit circle to get the exact answer. Now, you can use your calculator to get these answers as well, but look what happens when you do that. Right? So if I want cosine inverse of, let's do 0 because that's the easiest one for me to type in. Right? So if I do cosine inverse of 0, I hit enter. Now my calculator doesn't tell me pi over 2. It gives me the decimal value for pi over 2. I accidentally hit the enter button twice, which is 1.5707 and so on. Right? So you can use your calculator to evaluate any inverse trig function, but if you need to give the exact answer, which usually you do, pi over 2 is the exact answer, 1.50796. That's an approximate answer. Now for some of them you might be able to figure out, 1.57, that's half of 3.14, so that's pi over 2. Maybe. But the one that you get for 2 pi over 3, you're going to be able to figure out that decimal number is 2 pi over 3. Are you going to be able to figure out that the decimal you get is 5 pi over 6? Maybe, maybe not, which is why we use the unit circle to get the exact values for our inverse trig functions. All right, so that's a few examples of evaluating the inverse cosine function. Hopefully it made sense. Remember, key things for inverse cosine, top half of the unit circle, and I'm looking for the x-coordinate. Whatever number they give me is the x-coordinate of the point that I'm looking for on that top half of the unit circle. And then I give the pi number as my result. That's how we do inverse cosine. All right, so if you haven't seen the other videos that I've done on the inverse sine function, the inverse cosine function, check those out. I'm also going to do some now on inverse tangent, so make sure you look at those as well so that you get a full view of these inverse trig functions.